Next, internal fields in liquid and solid. So what is the internal field of liquid and solid in the dielectric material? See here, okay. The internal field of the, or we can say that a local field, okay, in the electric local field is the electric field that acts at the site of any given atom of a solid or liquid. The dielectric subjected to the an external field and is resultant of the applied field and the field due to all the surroundings dipoles. Okay? This is called the internal field. Okay. Now second one is expression for the internal field. What is the expression? Consider a dielectric material either liquid or solid. Dielectric material either liquid or we can say solid. Okay. Kept in the external uniform field. Kept in the external uniform field. Okay, that is E still. In the material, let us consider an array of equidistant atoms. For example, you'll take the X atom is there. The distance, another one is the A1, then this distance is A2, B1 you write, then distance is C1, like this. Okay, or same distance it is the A1 means A2, B2 and C2, like this. So all is separated by distance D, equidistant. It is kept in the electric field, the atoms. Okay. So let the internal distance be D, okay, B, and the polarization and the electronic polarizability of the dipole is alpha E, electronic polarizability. Then the expression for the internal field can be written as E of internal field equal to external electric field plus 1 minus 2 times of, okay, electrical polarization divided by pi of mu naught epsilon naught into dq. This is the expression for the internal field. Okay. Once. Or next, Lorentz field. What is the Lorentz field? Okay. In the equation, okay, the above equation or the standard equation of that equation 1, Le, E and E naught, okay, and D are all positive values. Ne, E, okay, alpha E, D, Q and E are all positive. Therefore, internal field is greater than the applied field. So the equation 1 becomes, has been obtained by the condition or contribution or constituting the one-dimensional array of atoms. But when three-dimensional array of atoms, the general equation of the internal field will becomes like this. Okay, when three dimensions, E plus of gamma of epsilon naught into of P. Okay, that is it. Where P is the polarization and gamma is the propagation of constant, propagationality constant or proportionality constant we will take, and this is called an internal field of constant. In three-dimensional, it is a cube lattice. In three dimensions, it is a cube lattice is there. Therefore, the gamma can be written as 1 by 3 times. So 1 by 3 times. Now, okay. Now the internal field for this Lorentz force can be written as E Lorentz, okay, equal to E plus of polarization divided by 3 times of epsilon naught, called as equation number 2. Okay. Or he may ask in the another way, what is that? An important equation based on that. Yeah. Okay. Or we can say that Clausius, okay, Masoti equation. Okay. What is this? See, I consider an electric field here. Okay. For the dielectric material, of the dielectric constant ER, if n is the number of atoms of and per unit volume of the material, and mu is the atomic dipole moment. Mu is the atomic, n is the number of atoms per unit volume, mu is the atomic dipole, and dipole in the dielectric constant. These for the dielectric material. These are the notations are there. So according to that, the dipole moment, are you able to see here? Huh? Dipole moment, okay, per unit volume can be written as n into u, called as equation number 1. Okay, the field experienced by an atomic key is the internal field. That is the internal field. Therefore, if alpha E is the electronic polarizability of the atom, then we can say that, okay, the mobile dipole moment can be written alpha E into E of I. This is called as equation number 2. Okay, now the dipole moment per unit volume. The dipole moment per unit volume is n into, okay, mu is equal to alpha E. Mu is alpha E into EI can be written. This is called as its left side of the is the same as a polarization. This left side is same as a polarization. Therefore, the P is equal to n of alpha E into EI can write, or E of I, okay, equal to, okay, P divided by n into alpha E, okay, called this equation number 4 or 5. If it is 4 or 5, okay. But we have the relation of polarization. What is the relation of polarization? P is equal to epsilon naught into epsilon r by minus 1 into E. This is the equation of polarization. Okay. So there E is the applied field. Therefore, E can be written as P divided by epsilon naught into epsilon r minus 1, called as equation number 6. Okay. Now the equation of the internal field can be this equation of the internal field E equal to E plus of, okay, gamma into P divided by epsilon naught. Okay, this equation number is 7. So gamma is the internal field for a constant. Substitute these equation, okay, 5 and 6 in the 7. This equation of 5 and 6 in the 7. So right here, EI is equal to how much? EI is equal to what is there? P by n into alpha E is there, equal to E is equal to what? P divided by epsilon naught into epsilon r minus 1 is there, plus, okay, what is that? Gamma, as it is gamma, okay, into P divided by epsilon naught. Okay, wait, this value is there. So what is P get common, therefore, so 1 divided by n into epsilon E, so 1 by epsilon naught will be taken common, so 1 by epsilon r minus 1 plus of gamma it will remain. Okay, but we know the gamma is equal to 1 by 3, therefore 1 by epsilon naught is equal to 1 by epsilon naught minus 1 plus of 1 by 3. So this, now we will take up epsilon naught divided by n into alpha E equal to, okay, so take the LCM for this, okay, take the LCM, or it will become 3, this will be 3 plus of 1 means 2. Rearrange the term, what will go up, what remains here? Wait. 1 by epsilon r minus 1 plus of 1 by 3 as it is now. Okay, now, so epsilon naught by n of alpha E can be written as above arranging the arrangement is 1 by 3 is there. So take the common LCM, epsilon r minus 1 into 3, okay, here 3 minus of epsilon r minus 1 is there, so that this may be, okay, 3 minus epsilon r minus 1 divided by 3 will come here, 3 of epsilon naught by n alpha E, so this it get cancel, 3 minus 2 is there, this is plus, this is minus, then 2 minus epsilon r is there, 2 minus epsilon r, okay, divided by epsilon r minus 1, or we can get epsilon r plus of 2, epsilon r plus 2 minus of epsilon r plus 2 divided by epsilon r minus 1. Okay, or here 3 epsilon naught by wait n or you or you can take here epsilon r plus 2 divided by epsilon r minus 1 one side. This will be the n of epsilon e by 3 of epsilon naught. Okay, so this equation is known as called as a Clausius, okay, Clausius Massur's equation. Okay,